Alright, and we're back with example 2. We're working on some more applications. The first one is going to ask us to graph this thing. So if you have not yet done so, you're going to need to graph this. So graph this now. I'm suggesting you use a t-chart, 0 seconds, 1 second, 2 seconds, until you figure out where it lands. And that's what I'm going to do in just a second, but I'd like you to have this done first so that you can come back and look at it later. Alright, so I've still got time and height as my variables. I'm going to do 0 seconds because we can't start before 0 seconds, and then 1 and 2 and 3 and 4 and 5. If I need to add some on, I sure will. So it looks like we have negative 0 squared, which is 0 plus 8 times 0, which says we have a height of 0. It looks like we have negative 1 squared. 1 squared is 1. Negative 1 plus 8, 7. 2 is going to be negative 4. Plus 16, which is 12. 3 is going to be negative 9 plus 24, which 9 and 24 give us 15, I think. Yep, 15 feet. 4 is going to give us negative 16 plus 4 times 8 is 32, so that's going to be positive 16. 5 is going to give us negative 25 plus 40. We have 15, which looks like we're going back down. 6 is, we need this one because we're not back down to zeros yet. 6 is going to give us 6 squared, which is 36. Negative 36 plus 48. 36 and 48. Then give us 12. It looks like we got a little bit of a pattern here. Maybe the next one will be 7 and then the last one will be 0 if the pattern follows. 7 squared is 49 minus, so it's negative 49 plus 56, 56, 49, does give us 7. Pattern follows, just says the last one should be 8. So then we get negative 64 plus 64, which does give us 0. Fantastic. Alright, we're going to graph this. So we've got plenty of space. I'm just going to skip over the line. So 1, 2, 3, 4, 5, 6, 7, and 8 seconds. So we get 0 and 0. And we only need to go up to about 16 feet. So I'm just going to count every other one and use my even numbers. So 2, 4, 6, 8, 10, 12, 14, and 16. So 0, 0, 1, 7, 2, 12, 3, 15, 4, 16, 5, 15. It looks like we're going back down. We've got our axis of reflection. 7, it's going to be at 7. And then of course we need to sketch this thing. I'm going to connect the dots. And this is the height of our graph. And again, I just use a t-chart. You could also use negative b over 2a to find the vertex, and then note that we have a negative 1 as well, unfortunately it's in standard form. So find the roots, find the vertex. I'd still might plot with the t-chart to figure out exactly where these points go though. Oh wait, exact maximum height. So our maximum height is 16 feet. What's the amount of time that the ball is above 7 meters? 16 feet because it's the highest one, it's the biggest number. Amount of time the ball is above 7 meters, which says that we have 7 meters from 1 second. This is above 7, this is above 7, this is all above 7, all above 7, all above 7, until 7. So from 1 second to 7 seconds is 1, 2, 3, 4, 5, 6 seconds. Which looks like this problem is not asking for everything that the last problem did. Okay. Looks like example 3. A swim team member performs a dive from a 14-foot high springboard. The parabola below shows her path of her dive. So she starts at 14 feet. She clearly jumps up. Oh my gosh. She jumps up really high. This is 20, 22, 24. She jumps up to 23 feet. So from 14 to 23, that's a pretty big jump. I don't know about y'all, but hopefully she's got a little spring. Well, it says springboard. Okay. Axis of symmetry. So where are we at? Where are we the same on both sides? Looks like we've got our vertex is at this point, which is 3 something. So I'd say the axis of symmetry is the distance from the springboard. So maybe our d equals 3. We said find f of 6. That's looking at us to find the graph. So at 6, when we input 6, our output is going to be, so input 6 feet, output is going to be 14 feet as well. Okay, example 4. I'm okay with you guys trying the rest of these on your own. Come let me check these before I give you the practice sheet. And then we'll get a practice sheet, and again we got a test on Wednesday. Tomorrow's